So without further delay, our basic agenda for the webinar is we're going to have an overview of Creo import data repair functionality. The basic agenda will be just like I said, introduction to boundary systems, and then we'll have an import data doctor overview. We'll be talking about the import profile functionality specifically, and we'll also be working through some repairs and workflows and things to that effect, looking a little bit deeper into the functionality that is import data doctor. Okay, and we'll follow up at the end of that with some question and answer time. And I would encourage everybody when we get to that point to go ahead and use the GoToWebinar interface for asking questions. If not, we can, and if there are struggles with that part of the process or the functionality, we can unmute individuals and take individual questions and things to that effect when we get to the question and answer part of the demonstration. Okay, a little bit about myself. As I said, my name is Sean Farringer. Kind of the boundary systems manufacturing specialist, if you will. Been working with PTC products since about 2001, roughly. The duties I typically get called for would be training, consulting, implementation, things to that effect. A little bit about boundary systems. Boundary Systems is technology leader. Obviously, partners include PTC, eTraj, other technology companies. One of the 16 fastest growing companies in the greater Cleveland area. Overview capabilities are listed here. Product lifecycle management, design and consultation, simulation, product development, etc. A handful of the customers that Boundary serves are shown on this slide. Some awards that Boundary Systems has received in the recent history, if you will, are kind of listed on this page to kind of give you some context of Boundary Systems accomplishments, if you will. Okay. And a little bit about the solution page or the solution overview of things provided from Boundary Systems encompasses the greater share of the products listed you see here on the screen. Contact information for both myself and the sales team at Boundary Systems is listed on this slide. When we complete the webinar and we're looking at the last slide, my contact information will also be on that slide as well as the sales contact information for Boundary Systems. Okay, with that, we'll go ahead and begin our webinar here this afternoon. Okay, so what we've got here is the home page on Creo Parametric here. We're going to start looking at this first blank start page, if you will, of Creo Parametric. We want to start here because we're just going to start with a little bit of overview about Import Data Doctor, and this is where we'll speak to our import profiles as well. A little bit about where we're going with this webinar is the Import Data Doctor environment and import data repair, if you will, within the Creo Parametric world. Use the Import Data Doctor interface. This is the place where we're going to go and fix up the typical problems that typically occur when we're importing files from another system provided in a neutral format, if you will. Something provided to you as a step file, or alternatively, a worst case scenario, maybe an IGES file. I typically remind everybody during these webinars, if it's not a big deal, but friends don't send friends IGES files if you can help it in your interactions with your clientele and others. In the modern era, it is much better for everybody involved if we're working with primarily a step file, or alternatively solid files work in the overall ecosystem pretty well also. But IGES files, for a host of reasons that would take up the rest of the webinar, are arguably maybe not the best idea to start with if they can be avoided. The techniques and the things that we'll do in the context of this webinar will be applicable on IGES files, but typically you're going to have a lot more repair with IGES, and the overall underlying quality of the surface topology will be something typically less than, notably less than, what you would encounter with step files and solid files, respectively. So keep in mind, if you can avoid the IGES implications in the neutral file space, it probably helps dramatically. But the context of the BDC import data doctor is where we're going to go fix and repair or get these things corrected and get back to what is arguably, a solid knitted model that we can perform solid-based topology operations and things to that effect on. Now, one of the things that is related to the import data doctor environment that is accessed and managed here on our homepage is the profile editor. We access the import profile editor by the pull down you see listed on the screen now, and you see where we can go into a specific option for import profile editor. I show this because not everybody, typically our work is not on the home screen, if you will. So a lot of these little tidbits that might be hidden on the home screen kind of tend to be out of sight, out of mind, and maybe not everybody finds this stuff on their own. So this is where you're going to go access your import profile editor. Now, we're going to speak to import profiles as we import this part, work through and review repairs and things to that effect on the part. You'll see the backside of the creation of import profiles. But in order for all of that to make sense, we want to see where these profiles came from and how they're created, and that's managed in the interface that I'm showing you now. Here on this dialog box, we have control for what part templates would be used, how surface topology is handled, how curves, points, direct modeling, miscellaneous things, and the topology tab, the primary topology tab. The complete flavoring, for lack of a better description, occurs through these settings about how the object is going to be, whatever it is, be it a step file, IGES file, parasite file, whatever, how we're going to go ahead and import this file, and what settings will be in play when we do that import are governed by either these profiles or the settings you use live on the fly at the time of import. And we'll also see a similarity to this dialog, obviously, then, because all these same settings are presented to the user. However, it typically makes sense to go ahead and set up a couple of profiles that are conducive to the type of importing and the nature of things that you'll be working with at your location. So with that being said, this is where you would go and establish those profiles and set those flavors up about how you would want to import things. I'm not going to dive into these specific settings right now. I'll spend more time talking about those when we look at the two typical profiles that I have established that I typically use to import parts with and how that process goes. But this is where you'll go create those flavors. When you create one, you will save the import profile here using the save icon as far as, to save this rack of settings. Now, that being said, I've got to jump in here and bring up my config.pro real quick so I can speak to the context of exactly what what is involved in getting that directory to be assigned, as far as, knowing making Creo know where to go get these files. That occurs by a typical directory call out config.pro setting, and I'm going to highlight that and put that on the screen right now. I encourage everybody to use your snipping tool or something to that effect. I'll leave it up here for the next 10-ish seconds or so, if you will, and hopefully everybody gets a chance to snatch the actual setting itself. Obviously, the directories that you see here wouldn't be applicable. You would point that to where you have stored these profiles you create on your own local system. But the config.pro setting that I have highlighted right now is where you structure that in your own config, in your own environments to make Creo know where the profiles you save are, so they can be selected on a pull down that you'll see moving forward here soon. So by all means, my contact information will be up at the end of this webinar. If for some reason you didn't get a chance to snatch this config setting during this time before we move on, don't hesitate to grab my contact information at the end of the webinar and reach out to me, and I'll email you back this config setting or whatever the case may be so that you can deploy this as well. It is kind of nice and elegant when you use the actual config setting, because then it provides for everything to be just on a pull down. You'll kind of see how that goes in the remainder of the webinar. But this is the interface, this is the location where you get it, and where you set up these import profiles that we're going to start working with now. So now at this point, we're going to go ahead and bring in a part file, or excuse me, a neutral file, which in this case will be a step file, that we're going to go ahead and bring in to a PTC part, and we're going to access import data doctor, and then we're going to go ahead and start working on this particular, object that we've got as an example, and using some different repair techniques and such to go ahead and go through some repairs and get it back to a solid model. So we'll go ahead and open up the step file right now. Can you just access that? Now you do have to typically do a type of all files or explicitly declare a step file or something to that effect, because PTC will naturally filter those out of your directory view. So we'll go ahead and say import. Now, if I haven't put anybody to sleep yet and everybody's paying close attention, you'll notice that this page looks inherently, different than the dialogue that I showed you before as far as setting up your profiles. But this is where you'll be presented with the pull down of stored profiles if you deploy the config switch that I just showed and had up on the screen previously. Okay, so this is how I have a couple of saved profiles, and we would access them here. Now we can alternatively set the details page explicitly at the time of import and not use a formal profile, and utilize the same type of settings and change these things on the fly by accessing the details page here. Now, again, if you're paying attention, this page, this other dialog that I have open now by accessing the details page, this is inherently very similar to what we were just looking at for the profile configurator, because it is essentially the same environment. It's just a question of whether or not you can save the settings that you're working with, and you are not able to save those settings that you use when you establish them on the fly at the time of import. In order to save a rack of settings, you have to formally do that as part of the import profile editor access that I initially showed during the webinar. Okay, so I'm going to go ahead and put this back for a second and speak to the two profiles that I typically work with on my own side for the importation of data. And this is irrespective of to whether or not I have a worst case IGES file or I have a best case step file coming from whatever other originating system. Now, you can see here I have two primarily listed as full repair and no touch. The current profile is the deployment of whatever on-the-fly settings you're using at this time in the dialog. Now, I have two profiles here. Again, I have full repair and no touch. And we're going to kind of walk through those quickly and at least get the highlights of the things that I consider to be significant within the setting climate of these two profiles, okay? So the first one, and the one that we will use to start importing this file, is going to be the no touch profile. Now, there's a significant reason in setting climate here that I deploy for the no touch. One of the things I don't do is use my own part template. The reason I don't use my own part template is because I want to check and spy on the accuracy of the model that the target, or excuse me, not the target, but the originating system used when the model was created. Because a part of repair reality is that you don't get back math you never have. And your own part template accuracy can in fact be higher than, or excuse me, if you will, better quality accuracy than what the originating system used. This adds to the problems that occur in the import of the file. If I model the originating file at, for just talking purposes, we'll say 1,000th English unit accuracy, and I was on my own part template, I was half of that in accuracy, and I was 5/10 English unit accuracy, I would in fact be trying to import the part to a far greater mathematical condition than what it was created at. And there are typically no good results that come from attempting to do that. You will not create the math or the quality of the topology that you did in fact not have to begin with in the originating system. So one of the unique and most powerful things about Import Data Doctor is its ability, if utilized correctly, and this ties into the importation of the part itself, if utilized correctly, you can deploy the part on exactly the same accuracy under which it was provided. And that's how we'll go through this process initially, so that you can understand what steps are in place to get to that location where you understand what accuracy you are given, and you can proceed from there using that same accuracy, which will make the repairs, not make the repairs unnecessarily difficult, or in some cases impossible. So finding that accuracy that was used initially is a nice, slick, unique thing to PTC, and we'll kind of go through that process as part of my no touch. Not using my part template is part of that recipe, okay? So we'll go ahead and look at the details page now. The single most significant setting for establishing the accuracy of this new model we're creating to be, in parallel with the originating accuracy is to make very certain that this model accuracy setting on the model page that I'm pointing at right now is set to external. You have three options. You have automatic, you have internal, and you have external. I typically don't let PTC do a lot of things automatically because I like to know exactly what result I'm expecting and how that's working. So I'm just, on a personal level, not a fan of automatic settings in the context of Import Data Doctor. Your mileage may vary. However, in this case, it is important that we use external and not internal, which would use our own part template accuracy, which if I say, don't use my template, and I say internal accuracy, it typically attempts to import the part to a relative accuracy 0.0012 part template, default from PTC. And I don't get my best results importing onto that format. So I will either declare my imports to be explicitly internal or external, but in the case of finding out what we had to start with, it's important to start with the external accuracy. It's possibly the most important setting on all of these pages now. But the key highlights, on the surface page, I make certain that it's not doing anything on the surface page. I just don't check the boxes, okay? Well, I'm not telling PTC to make any changes to the import as it relates to surfaces. The topology page is also very significant to me on the import profile configurator. I do not, in a no-touch climate, when I want to see what I was given as I was given this neutral file, I do not tell it to join surfaces from different layers. I actually never tell PTC to do that. I will sometimes tell it to go ahead and join surfaces from the same layer or shell as part of a full repair type of operation. I will also, in the no-touch, allow it to solidify a closed volume, but again, these three settings have the three options of automatic or yes, no, and I am explicitly declaring them. The defaults are automatic, and I do not personally work with either my full touch or full repair, or no-touch profile configurations in having any settings of automatic, okay? So in this case, I'm saying go ahead and solidify it. If I get lucky and we have a perfectly good knitted volume here without any issues, yeah, go ahead and solidify that by all means. But absent that, I don't want PTC to go make one of those in this case, or attempt to heal this geometry in any way in order to make a solidified closed volume, if you will. I also obviously don't have closed gaps or repair unsatisfied geometry checked, okay? Those are the big highlights in what I do in a no-touch initial import to get a look at my file, okay? So we'll go ahead and say okay to that. I'm going to go ahead and just recall my no-touch profile now, because that will reestablish all of those settings to be exactly what I just mentioned. Basically, I'm telling PTC to leave the topology alone, but if you can, and it's all fine, solidify that, but otherwise leave it alone, and let's go ahead and use the accuracy that was on the original modeling. So we'll go ahead and say okay to that, and now we'll proceed, or should we start the process of proceeding to import the file. Now, this isn't, fortunately, for the purpose of optimizing time in a webinar, this isn't an 80 meg step file. It's actually one of PTC's examples that if you download and install the full help system from the PTC website, much as you would download and install product updates, the full help system does have before we dive into the repair, I'll speak to this. It does have two key pieces of information for your knowledge moving forward. It has this part file and a couple of other examples embedded within a section of the Creo help system. And it also has a PDF file, and I'll go ahead and access that now if you give me a second just to kind of show it. It has a nice PDF file that is also available that covers a lot of the import data repair topics and things to that effect. So the actual PDF in question here would be Getting Started with Creo Parametric Import Data Doctor 1.0. This, when you download it lately, this will reflect the new interface to Import Data Doctor that was changed, if my memory is correct, somewhere around Wildfire 4. There was a big change to a more ribbon type environment within the Import Data Doctor climate, and everything now that you would download from the help file, or downloading in the help center, if you will, would in fact reflect the more modern versions of Creo, and it would be current with that. And you also can access these example files, and there are basically a couple of tutorials in there that walk through similarly to what we'll be doing here this afternoon to repair through these files and cover some techniques. And I encourage you to do so because there are a number of techniques that are outlined within the context of that PDF that we do not have the time to really divulge into in the course of this webinar, but they may be very valuable to you. Okay, so as we continue forward and begin to move forward to work into repair on this part, one of the things I want to mention that I think a lot of, or does me a great benefit personally, if you will, is accessing an old color scheme when I am working on a file like this for the purpose of import repair. I am very fond of the old purple over yellow pre-Creo color schemes for working on, import files and things to that effect. Anytime I have to do something like this, I do typically load an old system color file. If you have access to such a thing, I might encourage the same. It provides for an excellent contrast with the purple over yellow to show exactly where we have our problems on the file and make it visually easy to see. Okay? So just a little something from the personal side. I share there about my own color preference, if you will. All right. So here we are with our part, and based on the colors, yellow is bad. So we have a notable amount of problems on this part that we're going to have to sort out to get back to some level of a solid model. So accessing the Import Data Doctor environment is provided by right-clicking on the import feature that you will have in the tree after you've imported this file and selecting Edit Definition. Okay? But before we do that, we want to go take a look at what we were given for this file to get some kind of context about that originating system accuracy. Well, because we imported it with external accuracy, and we told PTC to leave it alone in this case, we can access File, Prepare, Model Properties from the pull-down menu. This allows you, by accessing this interface, this is where you would typically set model accuracy, but in this case, we're going to use it to view model accuracy. And in this case, when I access this dialog for the model properties, we see here that the absolute accuracy has been declared and defined at 0.066 something something and change. This is the originating system's accuracy for this part. And we have imported it effectively into that accuracy and not tried to make it better than it was or let it fall down and be worse off with, a greater course or accuracy, if you will, also. We've kept everything spot on where it needs to be. The model accuracy is currently set to this. So as we attempt to produce repairs moving forward, we are doing those repairs equivalent to the originating system's accuracy. So moving forward, we're not suffering unnecessarily so, and we're not letting things get worse off than they were to begin with. And this is typically the Goldilocks place that you want to do your import repairs if at all possible, rather than struggling to make things better or letting them become worse. So at the end of the day, this is the math you were given. You will not get back math you did not have. So this is your model accuracy, and this is typically where we would move forward with repairs. Arguably, that's a pretty unfortunate accuracy, and it does in fact have some degree of speaking to a file that has this many problems. So the lesser the accuracy on the originating system, the far more likely you are to encounter notable difficulties with the export of that file and then the subsequent import to some other system later. So with that being said, we're going to go ahead and start our repairs on this part now. And again, we access this environment by right-clicking on the import feature and saying edit definition. Now we are in the import dashboard, for lack of a better description from PTC. The little hospital or little medical looking button here is where we enter the IDD editing environment. This is where we go get to import data doctor. And we see right now that even though I said go ahead and solidify closed volumes, there was no closed volume here. We have a notable number of gaps on this part. So in this case, the system's automatically switching into surface mode, and that's how it sees the import to be valid. Now we'll access this Enter IDD Environment button to go ahead and get started with Import Data Doctor. This dashboard is the core of the environment you will work with to do the greater share of the repairs that you will do. It provides for the different functionalities of Import Data Doctor that allow you to do different types of repairs on different types of topology objects. Primarily, you're going to work with surfaces and curves, or shall I say, in the context of Import Data Doctor more often, surfaces and their boundaries or edges, okay? So in this case, we got to start the discussion with our component tree over here, or import feature tree, if you will. We see that there's a couple of objects listed here. We have a component and we have a surface. Now, we got to take a pause a minute here and describe this and discuss this, because it ties into the bigger picture of all things Import Data Doctor in ways that aren't always obvious to folks. We have a component. I would encourage people to look at that like an assembly of surfaces, and that's likely why PTC refers to it as a component. This is an assembly of surfaces. The system sees this as an assembly of surfaces, okay? When I select it, I am picking all of those surfaces of that component listing there. But it isn't a component. Don't confuse it in the same component context you would take from assembly mode, where we're talking about components in the context of full-bodied solid models. It's just what they called it here. We could call it a quilt component or a surface component, but it is an assembly of surfaces. Now, the other surface object, and I will select and zoom in on that, we see that that is a particular surface right here that's highlighting on one corner of the model, and it's a surface by itself, okay? Now, it is obviously not an assembly because it's in the singular. Now, it's worth noting at this point that my repair icon that everybody likes to start with, and there is no measure of how much I discourage people to start that way, where they just import the part and keep stabbing the repair button until something positive happens, if something positive happens. The reason that you can't, or we can't do that in this case is because we have multiple components over here, or multiple objects, shall we say, in this tree, and the system doesn't know what object or component, if you will, is active. It's basically sitting here saying, repair what? Repair is an object action workflow, so in the absence of having a single component in the tree. So we have to get to a place where there is one component in this tree before the repair icon will essentially come to life. If you're attempting to get to a solid model, that's where you're going to need to be anyway at the end of the day, where you essentially have a single assembly of surfaces that creates a knitted volume that can be solidified into a solid. So in this case, we see that surface exists as an extra, if you will, and then we also see when I select the component that it also has one of those surfaces in it. There are two of them, essentially. We have one inside the context of this component, and we have an extra one that was essentially duplicate for whatever reason in the import. So one of the nice things about Import Data Doctor is its understanding of our beloved delete key. So all I have to do right here in this case is go ahead and delete that surface. Now, as soon as I had the surface selected and I actually clicked the delete key on my keyboard, as soon as I did that, you'll notice that the system recognizes we have a single component now, and as soon as I did that, the repair button activated. So I could theoretically now come up here and click repair, and then the system will attempt to repair the whole object, all of it. All of the topology will be put essentially into the loop of repair, if you will, in the mindset of what are we going to try and process repair on. I discourage doing this greatly. Not all of this file is a problem. Why would we push into the repair environment the surfaces, for instance, on the back side of the topology, such as the one I'll highlight here, where we don't have a problem with that current surface. It doesn't need any repair. There's nothing adjacent to it that needs a repair. We don't need to do that. So what generally works a lot better is to treat the repair key as object action, regardless of what context you're currently operating in the tree, if you have multiple components or not. So typically we might do something like select this surface and then select the surface adjacent to it, and then say repair, and see if PTC will zip that up and repair that surface in that case. Now, here we see that that's not going to happen automatically. When we see a green edge, and I'm going to change my highlighting here so I can point at things. When we see these green edges, if we see one of those green edges being created where this open edge is known to be on the model, then you know that will be taken care of as part of the repair process. It is going to clean that up when it turns it green. Okay? In this case, it didn't. So we would need to use a different technique in order to repair this area of the model. There are a host of different ways to go about putting this back together right here for us. We'll kind of walk through a handful of different ones here. We have a bunch of different gaps around here. One of the things we can do is set my selection filter back. We can select an edge on the model. So we have a gap down here where this edge is pulled down that I'm currently highlighting. I can then come up and say, I want to replace that edge from the ribbon, replace being my ribbon option. I then select the edge that I would like that to share or use or be equivalent to, for lack of a better description, that exists on the model, what I believe to be the adjacent good quality surface edge, and then say OK. And we see that it will zip and repair those two edges together. Now that we see that that edge has turned purple, we know that the surfaces have in fact been merged, for lack of a better description, and that is no longer an open boundary problem on this model. You can undo Import Data Doctor repairs. So if I come up and I click the undo option, I can undo that repair. If you perform a repair of any type and you don't get the result you want, but it doesn't go into failure mode, sometimes this does happen, I encourage you to undo that. You know, don't just leave that repair that didn't provide a result you were targeting in the queue of things that were repaired. It can in fact cause more problems later than it did any good to solve. Okay? So another thing that we can do is heal gaps and slivers. Okay? There's a couple of different ways to get into gaps and slivers. Now, one of the ways that's popular, but this model has gaps and slivers that are too big to deal with in this way. You can search for gaps. Okay? Gaps are searchable with the search tool. So I can pull up the search tool from the status bar and give it a value for maximum, or excuse me, you know, a maximum, and then say less than gap size. And I typically just put a very large value in here and let it go find all the gaps if I'm going to attempt to do those types of gap heal operations. And Creo will go out and find all of the gaps on the model for you and highlight them and kind of work through expediting some of the manual gap healing process, if you will. Now, the more manual gap healing process works like accessing the gaps and slivers icon on the ribbon, and you declare these gaps as you go along. For no good reason would you typically uncheck the add to wireframe. A gap has to be added to the wireframe to be repaired as part of a repair operation. So it is typical that you will always leave add to wireframe checked here when you're declaring gaps. So you simply select on a gap area, and that will put the gap in the first collector on your define gaps, you know, dialog. Then you must activate the second collector and select nearby that same gap. Okay, and PDC will know what you've already picked and give you the other thing. I give you that workflow because that can be helpful for making filtering of this. So you're not struggling to pick the right thing, if you will. If you use the dialog, you get a little bit of automatic filtering there. So that's how we would declare a manual gap in this case. And then say, okay, now we've added that gap to the wireframe and we've declared it manually. So when I go back and I select those two surfaces and I access my repair again, so again, I'm doing a surgical repair. I'm selecting the two surfaces that are problematic, and I'm going to go ahead and say repair then, so I only repair on those surfaces. Now we see that line, or where our gap was, is now green. Now we're going to get our repair of that gap. And you see here, sometimes when you do it this way, you get more for your money. We didn't declare this gap down here that was present on the model, but it was repaired as part of that process. This is why I encourage people to kind of work surgically and simply and not try and throw the bucket of repairs at everything at one time, because you'll generally have a better process walking through that way. Okay? So, and then we might follow that up with what we did right there with a replace operation, like I just showed, where we would come up and say replace, and then select that other edge, and away we go. And now we've repaired that all the way around to where we actually have a surface missing. If I were to go back into shaded with edges mode, and give it a second here for your screen to catch up, you'll see here now that I'm in shaded with edges mode that we have a missing surface here. We have a surface that we're going to have to create. I mean, it didn't exist. We didn't get it from the original model. So we're going to have to fill that in, and that's why we have the gaps present that we do in this case. Okay? Now, because we have this, and this surface is missing here, that replace type of operation and zipping gaps can be problematic in this area where I'm pointing to right now on this edge in the model. That can be a problematic type repair because that adjacent surface is missing, and the system doesn't really necessarily have all the things down there in that corner that it might like to use to heal this, because there's somebody missing here, if you will. We clearly have notable problems here on the corner of it, where it's still very much gapped out down here on the corner, and we can see that on the shaded model as well. So what I'm going to go ahead and do now is go ahead and switch back into the no hidden mode, so we can see that in those purple over yellow colors. And I'll speak to a couple of other functionalities here moving forward about ways you would typically repair a part. Now, something that is available that I personally use as a last resort, but many folks are very comfortable with this technique, is move vertex. This allows me, if I say move vertex and I come down here and I select this vertex on the surface, I can click, hold, and drag the corner of that surface into a visually better place. A lot of times when I do that, you'll see here that it kind of healed up the model right there. Okay? Now, we healed up the model in this case, but it may or may not have been the repair I wanted for. And we still have issues with what's going on with this surface being missing and, a gap here, etc. So one of the things I'm going to do is show the more elegant, in my opinion, way that all of this would have been solved on this part involves a little bit of what we call the collapse technique. So I'm going to go ahead and undo some stuff here to kind of get back to where we were. And this is kind of where we started. And we can go ahead and do some repair on this edge over here now, and we'll go ahead and repair that open edge right there. I just selected those surfaces and did a repair. But I have a big problem with this big surface here. Well, this guy isn't wildly difficult. I mean, that's a pretty, flat, easy, whatever kind of surface. So I'm actually just going to select that because I know that the edges adjacent to it are good. My problem is on this surface. So I'm just going to go ahead and blow this away and delete it right out of the model. So now it's gone. I got rid of that surface out of my component. And I'm actually going to exit Import Data Doctor now and walk back into Creo Parametrics. So now I'm back in the Creo environment outside of Import Data Doctor. So what I would do, and I'll kind of speak to this as I walk through, I won't take a lot of time for the screen to catch up and things to that effect as I go along. But basically, we're going to whip up a quick fill surface on those boundaries, and we're going to make it part of our import file. So what I'm going to do is go ahead and say I want to make a fill surface, and I'm going to declare a datum plane using the two good edges that I know are on the far outbound sides of this. And then I'm going to go ahead and project the chains that I know to be continuous and good here across my part. So I'm going to accept that. And I projected that chain that is continuous all the way around. And then I'll go ahead and drop a tangent arc in there in that corner where I know I need it to clean that surface up so I have a continuous boundary. If we go ahead and turn on our surface shading here, and I'll let the screen catch up a second, you can kind of see the context of the fill surface that I'm going ahead and creating right now. So now I've got this fill surface that I'm going to go ahead and put on here. So we'll go ahead and say OK to that, and we'll drop back out of the surface thing. Now, if I go into shaded mode here, you'll kind of see that now it looks like I have a surface there, and all things are okay. But if you were watching closely before I jumped into shaded mode, you saw that the entire perimeter is still yellow. It's not a closed boundary. It's not really part of this quilt. Part of the import. So what I can do now is utilize a piece of functionality that's a little obscure and well hidden a little bit, but is awfully powerful. So I'll go ahead and select both of these objects in the tree using my control key, and I'll go over here to the edit tab, and I'll grab my collapse function. Collapse is object action, so you have to pick the things first before it highlights. And I'll go ahead and say collapse. And then I get a little dialog that comes up and says, hey, how do you want to go ahead and collapse this stuff? And the defaults here are typically just fine for everybody. So we go ahead and say, okay. And now you see my surface disappears from the tree, but it doesn't disappear from the model. So what happened is it put my surface inside of what it thinks is the import now. So now when I go right-click and edit definition and go back into Import Data Doctor, and I access my Import Data Doctor icon, we see that I have new objects here in my tree. Now that I've done this collapse, I see the surface here. It's highlighted at the top of my tree. I see that I still have my component 251, and I also have a datums group. It actually brought that datum plane that I created on the fly into the import as well. Well, I'm not going to be needing the datum point, or excuse me, the datum plane, so I can just delete that away. Because part of the beauty of what just happened is the elimination in this unique case of any parent-child relationships that existed between that datum plane and that surface I created with it. Now, the surface is still unbounded, still separate from our component. Well, the cool thing is, because they gave us a tree like this, they set us up for the purpose of drag and drop. So now I can select this surface and simply drag and drop it into my component. And PTC will attempt to weld it into my surface topology wherever possible all the way around. Because I went and I built that surface outside using Creo Parametric, using all of the good edges that existed on the surface body to begin with, we didn't have any problems zipping the whole thing up all the way around. So instead of doing a whole bunch of surgical repairs in this case, I just fixed the whole boundary of this surface at once and kept everything elegant and contained to the import body in the tree. Now here within Import Data Doctor, I can go up and grab the Boundary Blend tool and go ahead and make a simple boundary blend that is a typical surfacing workflow for PTC. We'll make a quick boundary blend right here in this neighborhood where we're missing that surface, and then we'll go ahead and drag and drop him into that body as well. And now you see I don't have any yellow stuff on my surface spot, or excuse me, on my surface topology anymore. Everything has been fully knitted up and clean. Okay. Typically, you're going to get a feedback down here in the message bar that we have all been trained to ignore that says, now you can go ahead and use Solidify to create a base feature from a closed quill. That's your feedback that PTC is saying, hey, our work is done here. You have a closed quill. I can solidify this thing, and we can go on about our business acting and working on this like it's a solid model. So you'll typically get that when all things are good. Now, one quick thing before we step back out of Import Data, or walk our way back out of Import Data Doctor a little bit, and get into question and answer and some other topics. One thing that is key, I do want to note about Import Data Doctor that folks don't always discover either is when you access the Tools page on the ribbon and subsequently your Geometry Checks tab, you do have unique settings for IDD when you are in this environment. The Geometry Check Troubleshooter is different inside of Import Data Doctor and outside of Import Data Doctor. So you do have IDD settings here that you can control for the size frame of where you want thresholds to be generated for errors and, what errors are actually going to be shown. I can't stress enough. It doesn't make sense to uncheck the red stuff. You want to be told in this troubleshooter of the red things because those will be deal killers for getting a solid model. You will not be able to get a solid model in most all typical cases where you have any of the feedback of these red problems that are listed here in the IDD settings of of the Geometry Check environment. Okay, so be notable about this. We didn't utilize this environment to tell us where the problems are today because it was pretty obvious what was going on with this part. However, a lot of times you can import something and there can be an infinitesimally small open area on the part that is insanely difficult to find visually in this environment. By accessing the Geometry Check tab here within IDD, will allow you to zoom in on those things on the model. Because if there are problems listed here, you can click on them and it will zoom the screen just like it would in the context of accessing the geometry check world outside of Import Data Doctor. So be aware that there is a little bit more horsepower in here, and you do have some unique power with the IDD settings here inside of Import Data Doctor only. You don't see this IDD settings in that context when you're accessing the geometry check tab outside of Import Data Doctor. So we've got our solidified solid model now. We got our good feedback by PTC, and we can go ahead and say okay. Now, in this case, I can do one of two things. I can go ahead and take the green check mark and back out of here, and then select the quilt, and then select from the ribbon the solidify option, and I will have a solid model. Or because I've managed to solidify or close up the quilt inside of Import Data Doctor, I can also tell Import Data Doctor to go ahead and do the solidification here and use the solid option now, because it can be a solid model at this point. And then when I say okay and I get out, everybody will recognize the immediate change in wireframe color as being PTC recognizing that we now have a valid solid model that's been fully repaired, and it is of the equivalent accuracy to the model that we would have otherwise started with, or to the quality of the model that we were otherwise given when we started the process of importing and repairing this part. So that kind of takes us in a pseudo walkthrough from cradle to grave about accessing a few of the core functionalities within Import Data Doctor, seeing the level of horsepower and actual granularity with move vertex and other techniques that it can bring to the table to repair parts quickly and easily that you might struggle with that don't come to you as a solid model, and actually repair some fairly significant things, and we've replaced some things. We kind of covered a lot of ground. There is a ton of depth in Import Data Doctor, and again, I would encourage everybody to either follow up to us at Boundary Systems for more information as it relates to Import Data Doctor, or dig into the downloadable help system and dig up that PDF and this particular and other sample files, and you can continue some education in that direction as well. Now, with that, I'm going to go ahead and say we're kind of in the question and answer period here this afternoon for Import Data Doctor, and ideally, again, if we can, I'm going to go ahead and bring up the GoToMeeting question interface for myself now, and where I can review your questions as you ask them. So I'm going to go ahead and get this interface up for myself here and try and speak to the questions as they come in. But if at all possible, if you can use this question interface and we can speak to them that way, as opposed to me actually unmuting everybody or individuals, it typically does work a little better because we don't end up with so much of the background noise and some of the frustration that can sometimes bring. So I'm going to go ahead. I've got my question interface up now. We do have one question that was already inbound. I'll go ahead and read through this and speak to this here as we start to take more questions from folks. The question being, what happens if we reduce accuracy from that external, in this example, from 0.66 to, say, 0.1? I know this isn't numbers we're shooting for, but for an example. Okay, very good question. Very glad that it was asked, and thank you for it. Typically, you get the math that you were given. If I attempt to increase the quality of the accuracy, which means a reduction in the number that is declared for part accuracy, the number of import problems will increase, and unfortunately, typically exponentially, because we're trying to build a piece of topology. PTC is trying to figure out where all those surface edges are to a greater accuracy than they were ever declared to begin with. And that's the context of you don't get back math you don't have. Now, when you decrease the accuracy by increasing the size of the number, it typically does not make the part fall down in such a way that you get additional errors and additional problems with the imported geometry. Sometimes it can be helpful to increase the value for accuracy to be able to repair a very problematic file. However, by doing so, you are relaxing the declaration of the topology. The originating system declared it to be, in this case, 0.066. If we were to use 0.1, geometry that we would create moving forward would be no better than that 0.1 value that we use. But it would be not likely to negatively impact the ability of the system to import the file without errors and without increasing the number of open edges that are viewed on the imported file. Okay, so, next question. Is there something similar in Creo direct modeling? Not that I am aware of, unfortunately. There may be, but we're bumping up a little bit against my experience with that question because I am not anywhere near as well versed in the Creo direct modeling environment as to what I am here in Import Data Doctor, but I don't know on the face of it for certain that this environment has been duplicated inside of the Creo direct modeler. I haven't heard that it has, so I do have a little bit of suspicion that it might not be. So unfortunately, that on the face of it, we have to assume no, but I suppose it's possible, and I say that because of my lack of experience with the Creo direct modeler. Okay, can you show us a quick view of the settings on the full repair setting you use for importing a file? Absolutely. Let me pull that stuff up here real quick. So let me go ahead and say, I'm just going to go ahead and open we're going to go ahead and open and import the file again so we see this dialog. So I'm going to my full repair settings now, and I'm pulling up the details page for the full repair. Now, I'll kind of put these up for a few seconds, and then I'll move on to them, and just hit the key settings as far as that goes. I use my template in this case, but even though I declare the model accuracy to be external, it will in fact still use the accuracy that is on my template, which is why we didn't do that the first time around. I let the surface page go ahead and do everything but reparameterize the non-analytical surfaces based on arc length. There's never a time when I check that box, personally. The topology page is the other big ticket, and you see here on the topology page, I tell it to close gaps and do everything else is a yes based on what we saw earlier. For all of my settings that were no, again, the exception being solidify the closed volume. I do let it close the gaps between surfaces, but I do not repair unsatisfied geometry. If it does something there, I guess I lose the confidence to know it's doing what I need it to do, so I'd rather it do nothing in that context. I mean, your mileage may vary. I have to be very careful about molesting the import file a little bit and turning it into something it's not. So I am reluctant to deploy that setting under all circumstances because the surface topology will be affected by these settings. I am very reluctant to do the full repair that I have here. I will always import a file with my no-touch setting and see what I am dealing with ever before I would attempt to do one of these full repair imports. But those are the big ticket pages and the changes that I have between my no-touch setting climate and my full repair climate. Okay, next question. The IDD is standard functionality. There are no additional licenses or extensions required. Absolutely, to the very best of my knowledge, that is the case. If you go back in the history far enough, I'm not sure that like 20 years ago with PTC that it wasn't licensed in a separate module or something like that predates my own experience with the product. But as far as I know, in my whole experience with the product, I've pretty much known it to be standard functionality. So everybody should be able to access it in the way that I showed on any standard Creo license. And if you can't, I would strongly encourage you to reach out to us on the technical side or your current reseller directly to PTC. Reach out to somebody because it sure seems like you should have that functionality. Okay, more questions. I've spoken to the list of questions that I currently have on my screen right now. If we've got more questions, I would definitely encourage people to use either the chat interface or the full question interface. Okay, we got some more questions coming. Excellent. Does IDE work when import things using Unite technology? I can't speak to that explicitly, but I want to say probably if Unite expects to end up with a solid model, Unite technology might supersede import data doctor. I am not certain that they can be used fully in parallel. My lack of experience in interacting with Unite technology and systems other than PTC is showing there a little bit. You may have some functionality there, but I would expect that Unite to kind of take ownership of importing the file and getting us to a solid model if we're set up to do so accordingly. Can I share my contact details? Absolutely. That is part of the end of the webinar, but I'm reluctant to put that up until we're kind of finishing up because I want to be able to speak to questions here in Creo. So I'm going to pop this PowerPoint back up that does have my contact information on there. We'll keep this up for a couple seconds as the questions keep rolling. So just bear with me. If I need to switch back to Creo, I'm going to go answer a question with Creo, and then I'll keep popping this contact information up after I answer the questions as they keep rolling in. So if we have two models in a mold design have different accuracy, what should I change? Okay. Very good question. I do have a strong personal opinion on this that I will share with you, and I will, I preface it by saying this is my own personal feelings as it relates to mold and dealing with these types of things, et cetera, on the mold side. I stand by the statement that you don't get back math you never had. What I typically do in a mold universe would be to import the client part exactly as you saw me do today during the context of this webinar. I would be told by that client part exactly what kind of accuracy in their end game they are looking for. Now, this typically starts a discussion with me on this side where I would push back to my client and say, you gave me a part of 0.066 accuracy. I have to match the things I do in tooling to the part that you gave me, or I have to remodel this part because we're not getting this math that we didn't have if they would be asking for an accuracy that was greater than the reference part they provided me. So what I typically do is match all of my tooling to the reference part. That is as good as the job will be because that is as good as the file they gave me. If, in fact, they would be looking for tooling in all things to have a greater accuracy than that, then everybody would likely need to take a deep breath, and either the originating system needs to improve the model accuracy to an export standard that allows me to use that accuracy on my side, or somebody is going to remodel that part at that accuracy, or you just don't have that math that you would want from that accuracy in the actual underlying model. That math would not be declared in the topology. So that's kind of the context of how I handle it in the nature of mold, in so much as that if we have mold, the whole project is going to match the best reference accuracy I can have out of the reference part, and that is going to be what I was given by the import of the reference part as the originating system created it. So that hopefully speaks to the mold question that we have there. Okay. If we have a condition where the customer will not change it, well, then the customer would clearly want the model accuracy that they gave you. And if they didn't, well, then somebody's on the hook, or something is going to happen with remodeling that part. If they would design it, just to speak to it, I'm going to pop Creo back up for a second. If we were looking at this part as our reference model, and I'm jumping here into the file prepared model properties so I can have a nice English units discussion about this, so bear with me, because we're actually going to go reset the unit formula here real quick. To something that, I can speak to in a typical sense. If we're looking at this part model accuracy now, and if this was our part to do tooling for, when we speak to mold tooling, just in context, the absolute accuracy in inch units for this part that we just repaired was 2.5 thousandths roughly. By typical mold making standards in 2017, that's big enough to drive a truck through that. So I would be talking to my client saying, okay, are you looking for tooling that's 0.0012 or 0.0026 model accuracy, or do you require something better than that? If you require something better than that, we have to start with a better file. It comes from somewhere, because right now there is no math in this part underneath of this number. So I just don't have it to provide them in the theory of topology. That's as good as that part is. And I can either make the tooling equivalent to that, or I can suffer terribly by trying to make better tooling than my reference part. That typically is a very difficult workflow where you're going to encounter enormous problems inside the mold environment by trying to create features using the reference part at an accuracy that the reference part doesn't even have. So that's how I handle it. That's how I speak to it. If the client won't change the accuracy, I either have to work with that number I have on the screen, or I have to remodel it on my side. And typically, I require a requote on that myself if that were my own personal work or something to that effect. So hopefully that kind of speaks to how I would manage that process of dealing with client accuracy. I don't see any other way around it, because I don't get the math I don't have. So is the match command worth using, or just stick with the gaps and slivers command? I do not use, on a personal level, I do not use match technology much. It does seem to work in exclusive conditions and stuff, but the conditions and the frequency under which I get a success from match is far fleeting compared to what I demonstrated using gap manual techniques. I don't attempt to repair things that aren't broken by doing global repairs and match and whatnot. I tend to stick to the declaration of gaps that I showed and using the repair functionality to bring them together. If I can't get a repair to fly in that case, it's very typical. One of those two surfaces is a bad operator on the face of it. It's just a bad surface. More often than not, you could be better off by, if you have to, use it as a template and just recreate it and collapse it in, rather than continue to fight something that won't repair with typical zip gap techniques, because that is very robust. So typically I might use match in a case here and there, but I will use the typical repair functionalities that I showed today more so than anything else. Question, never change accuracy. After I establish this number, if we're talking about this in the context of mold, or we're talking about it in part development, let's say I imported this blob, and I'm going to continue the development of the blob from here, but my responsibilities don't include mold on the back side of that. That's absolutely correct. This accuracy, until I'm duly informed by PTC with some modeling problem or something, is the new accuracy that I'm going to use moving forward for both the tooling and for continued part development. And I will not change that accuracy moving forward. And moving forward, I would only change that accuracy in a way that increases this number. Under no circumstances would I ever make an attempt to decrease that number, because it's very likely to result in enormous problems with the import file having far more open edges now that I have to go back and repair or other problems that will occur when PTC tries to declare a piece of topology and rewrite it onto your screen that was never that good to begin with. So yes, in the context of never change accuracy, after I have established this number like you see it here, I am done. That is the accuracy of this model moving forward unless I completely get stopped out and I am unable to create some feature at that model accuracy. Otherwise, I will continue to use it both in mold and in the context of part development. Okay, so that's the questions I have on the list right now. I'll go ahead and pop my contact information back up for a little bit here. If we catch another question here in the next few minutes, I'll go ahead and make sure to take those questions. Otherwise, I'm kind of already crowding everybody's time, another 10-ish plus minutes here for the day. So we'll probably work in a direction of wrapping things up if we don't get some good input on the questions yet. So increase accuracy of lesser model to the upper one. If you're speaking to mold tooling, no. I think we're not on the same page because there's going to be, when I start building and creating the mold, this is my reference part theoretically. In the beginning of the work, if you're talking about work that has already been started, then yes, you are using the lowest common denominator for part accuracy, whatever the reference model is. All of my mold tooling will be matched to that on a job that I start with. If we had to go back and rematch accuracy on something I was currently working with for whatever reason, I would work to get every object in the mold scope that was part of cavity touching and things that would be split out with volumes and things like that. I'm not talking about, ejector plates and the ejector house and the backers and stuff like that. The accuracy of those parts isn't as critical to you as obviously the stuff that touches your reference part. And in the context of mold, for me, this number becomes the lowest common denominator. All part files will get matched to that number. End of it. If I start with that number, I know there is never a problem getting all of those files matched out to that number. So that's how I would work to get things recorrected if I found myself in a situation where I had different accuracies and all this. The reference part is your Bible, and the reference part establishes your accuracy for the scope of the tooling for anything that touches or intersects the reference part in the context of how we would say to do things formally, if you will. Okay. Now, in the context of a multi-cavity mold, where we're dealing with a family mold, where we have, say, dissimilarities or not equal topology, in the context of something like that, we do have a potentially enormous problem on the face of it. And yes, in that context, the lowest accuracy I can get to is the accuracy I'm going to use, or the greater, I guess it probably makes sense to say, the greater of the two part files accuracy will be used. So if I have one part file that is .001 English, and I have one part file that is .002 English, we're going to set up on .002 because I'm probably not going to be able to get that part to go to 001, and then all of the mold tooling will be built to .002 accuracy. So hopefully that gives some context of clearing up what I hope or what I think might have been some misunderstanding that I was generating by how I was answering some of the questions regarding accuracy on the mold side. Is feature recognition failures related to model quality? Absolutely. You are working everything at the accuracy of the model that you have, and the greater the accuracy of the object you were given to begin with, the greater PTC's ability to do good things with it. When you are given a grumpy model, you have a grumpy life, inside of Creo, because poor accuracy is not conducive to the creation of high-quality features. So absolutely, poor accuracy, poor quality on the accuracy side can lead to enormous problems in modeling as you go farther downstream, if you will. Okay. Okay, so let me pop my contact information back up here again, and we're pretty much bumped up here. Okay, what is the reason converting units to the model, say from metrics to English, the model fails to be a good model? I typically don't change the units on the model if I don't have to. If you're encountering that problem where we're swapping the units on the model and things are failing, my gut check is it's very likely you are dealing with a PTC part model that you are working with when you are doing that, where you did not import it as I demonstrated it in such a way that the accuracy of the PRT you are working with is equivalent to the accuracy of the imported body you started from. When I start with an imported body and I use that accuracy, I have never had a failure switching unit types if I am using the originating system's accuracy. I've never had just the unit type switch fail the model if I'm using the correct accuracy that I was given to begin with. Okay? So hopefully that speaks to that question about conversion of the model, back and forth as it relates to whether or not it was English or metric units. If I don't have to convert it, though, I typically won't. Related to the recognition. Okay, is feature quality related to feature recognition failures? Again, yes. Accuracy speaks to everything you do in the modeling environment, whether it's feature recognition or whether, in feature recognition inside the context of ITD, or just the building of features inside of Creo Parametric to continue modeling on the same part, or the building of features inside of Creo Parametric, for instance, inside of the tooling environment, where we are building volumes and cuts and things that are adjacent to, intersecting with, and Boolean operations based on the model itself. Absolutely. Accuracy and the quality of the model can make or break all of those things. Any poor quality on accuracy can cause enormous problems with the creation of any features, whether they are in the context of feature recognition or they are in the context of poor Creo parametric model. Okay, do we have any more quick questions? This is kind of getting down to the lightning round because we're starting to go late here. So if you've got another question, do your best to type that in right away. And I'll speak to another one or two if they can sneak up here real quickly. Otherwise, I haven't seen any questions come in here for the last probably 30 seconds or more. So with that being said, I want to thank everybody for their time and attendance this afternoon. We had a really good attendance here this afternoon, and I really appreciate the question and answer and the engagement and the folks that hung around for the question and answer, all of you. I hope everybody benefits from the questions that were asked by others. We typically like to do it that way so everybody can benefit from any one person's question. We had a really good question and answer engagement this afternoon, and I really thank all the participants for that and everybody for their extended time, especially the folks, again, that hung out past our scheduled quit time at 12:30 today. Most appreciated, and I'm grateful for the opportunity to go ahead and speak to these things and have a little bit more depth in the discussion for a bunch of folks that hung around this afternoon. So with that being said, we're going to go ahead and wrap up, and I'm going to end the webinar. My contact information, hopefully everybody's had a chance to snatch that off the screen. Don't hesitate to follow back up with us at Boundary Systems. If we can speak to more context and more things as it relates to all things Import Data Doctor. We're definitely here to help you more so moving forward, and hopefully everybody got some good stuff out of this webinar here this afternoon, and it provided for some good things everybody can go back and make use of right away. So with that, again, thank everybody so much for your time today. Everybody have a great afternoon, and we look forward to seeing you all in a webinar again soon. Take care and have a great day.